Hello everyone, welcome back to Enginuity Lab, your dedicated platform for learning CAD and CAE tools in the smart way. In today's session, CATIA V5 tutorial for beginner series part 19, we are going to explore one of the most powerful tools in the part design workbench, that is the dress up features toolbars. These features help you refine, enhance and prepare your model for manufacturing. So let's begin. Go to start, mechanical design and part design. Rename the part as dress up features. And click on OK. What are dress up features? Dress up features in CATIA V5 are used to enhance and modify the aesthetic as well as the manufacturability of your part. In CATIA, we have a powerful tool or toolbar that is called dress up feature toolbar. This one. This includes the fillets. The first one the fillets, second one the chamfer, third one the draft angle, fourth one the sailing, fifth one the thickness, sixth one the thread and tabs, seventh one the remove face, and this one called replace face. These are the tools available in dress up feature toolbar. So let's start by creating a simple part as a base. Create a rectangular block for this one. So I'm going to create a rectangular block first. For that I am selecting the XY plane and the sketch. Give the dimensions. This is 100 mm and this is 50 mm. So click on the exit workbench and give the thickness 20 mm and click on OK. Now our base is created. So fillet. First we shall start with the most commonly used feature, that is fillet. Click on the edge. Now you can see after creating the base, all the dress up feature toolbars are activated. So click on the edge fillet. Here the edge fillet definition is open. Click on the edge where you want to give the fillet or radius and define your radius value. Here it is 5 mm. I will left this is as it is and click on OK. You can see I will use another one. You can see the change. This provides strength to the object. You can modify the fillet radius, tangent propagation and select multiple edges. Use preview to verify and click on OK. Like if I double click here and I can add multiple number of edges. If I click on here and select the different edges I want to give the fillets, you can see there are 3 elements selected, and also tangent. You can change the tangency in propagation, tangency, or minimal. Okay, and you can preview to see your changes and click on OK. Now you can see this is called fillet. Is the chamfer tool. For that I am inserting a new body and I am hiding this one and just rename this as fillet and click on OK, and rename the body to as chamfer. Click on OK. Hide the body one. In the chamfer, right click, define in work object. For that I am creating another base which will be same as the fillet tool. I am creating it rectangle and give the dimension. This is 100 mm and this is 50 mm. Click on the exit workbench, give the thickness. Chamfers are used to remove sharp edges and improves part machinability. Okay, so click on the chamfer tool. Here you can, in the chamfer definition, you can find different options like the mode. There are different modes available: length and angle, length and length. Okay, here I have choose the length and angle option and click on the edges where you want to give the chamfer. Here I have selected 2 different edges. You can select 3 and 4 edges. Okay, and here you can give the length as per your requirement. This is length 1 and angle, so I am giving it 5 mm length and the angle is 45 degree. I can see the preview and click on OK. Now my chamfer is created. So chamfers are used to remove sharp edges and improve part machinability. So next one is the draft angle tool. For that also I am creating a new body and rename this body as, right click, properties, rename it as draft angle and click on OK. Now hide the chamfer and create the base for the draft angle. Here I am creating a square box. This is a 50 mm. This is also 50 mm. And click on the exit workbench. This is also 50 mm. Now I have created a cube. Okay. Drafts are essential for mold design. So let's click on the draft angle and you can find the draft types. One is constant, one is variable. There are 2 different draft types: constant draft and variable draft. Here we have to choose the draft angle is 5 degree, the first one. The next one is the select the face to draft. I can select this face to make the draft. And on the neutral element, here we have to choose the face which will be the fixed one. I am selecting this one. Okay. In face to draft, you can select multiple faces like here. I have to selected 2 faces, and the pulling direction will be face 3, face 1. This is face 2, face 1 and face 3. This is face 1, face 3, this is face 2, and the pulling direction is face 1, control by reference. Click on preview. Now you can see, and click on OK. Now my cube is changed. You can see the draft, or we can change the degree or angle to 15 degree. Now you can visualize the change. And drafts are essential for mold design. So this is draft. Next command is the sailing. For that, I am inserting another body and renaming that to sailing, and hide the draft angle body, and I will create another base object, that is a rectangle here. Click on the exit workbench, give the dimension as 30 mm, and to apply the sailing, click on the sailing tool, sail tool, and the sail definition window will open. Here you can find default inside thickness, which will be 1 mm. Here I am making it to 2 mm, and you can also put the default outside thickness as well. Okay. Here you can find faces to remove. Let's see this one. And click on OK. Now you can see one face is removed, and the thickness, inside thickness, is created with 2 mm. This is called sailing or sail. The sail features hollow out a solid part with uniform or variable wall thickness. Okay, you can choose the variable wall as well, but we will go detail in another video where we will cover the sailing command only. Okay, the next one is the thickness. For that, I am creating another body, and renaming that body to thickness. Click on OK. Hide this one. Now create the base feature. For that, I am creating another rectangle here, and this will be 100 mm, and this is 50 mm. And the height will be 20 mm. Now I have my base created. So let's give another thickness. Click on the thickness. Here this is showing default thickness value is 1 mm and default thickness faces. Click on the face like here, this one, and it's showing 1 mm. I can put it to 20 mm and click on OK. You can see we have added 20 mm thickness to our body. The thickness tool add material uniformly to the selected faces of a surface or solid. This will work on both the cases, either on surface or on a solid. We can put the thickness. This is especially helpful while working on complex surfaces that needs uniform wall thickness. Okay. While working the complex surface where we can create only the surface first, then we can add the thickness to the surface, then it will be a very helpful tool. Okay. Next one is the remove face. Okay. So let's create another body and renaming it to remove face. And click on OK. So remove face. For this one we need a base. To create the base, click on the XY plane, click on the sketch tool and create a drawing. This one tangent, this one also tangent to here. This radius is, diameter is, let's say 50 mm, and make this line is tangent to this circle. Dimension of this one is 30 mm. Also coincide this line to here. The same way, do the coincidence to here. And this should be coincide with the vertical axis, and this is 100 mm apart from the horizontal axis. Now click on this point, click on the circle, coincidence. Now use the quick trim tool to trim this one and this one. This line and this line are symmetric to the vertical axis. This is of dia 20 mm. This is 20 mm from the horizontal axis, and this is 5 mm. Click on the quick trim, remove this one. Now we have our sketch created. Click on the exit workbench, give the thickness. To give the thickness, use pad command, and here I am giving 10 mm thickness. Now my base is created. So remove faces. Here I will remove this face or this hole and slot from this object. So let's select the remove face tool. Here you can see faces to remove. Click on the face and click on here. These faces, you can see. You can directly click on OK. So this will remove this face easily. Okay. This is the use of remove faces. When we create work on remove face separately, I will explain more in more detail. Next one is, so next command is replace face. For that one, we will insert a new body. Right click and give the name, that is replace face. Click on OK and create the base first. For that I am creating a rectangle which will be 50 mm width length and 20 mm width, and the height will be, let's say, 10 mm. Okay. Now one base is created. I will create another bases, a circle which have diameter of 10 mm, and this is coincide with the horizontal axis. And this is 15 mm, and this one 10 mm. Replace face, how it works? Click on the replace face tool. This is the replace face tool, and select the replacing surface, let's say this one, and faces to remove, let's say this face, and click on OK. Now you can see that material is removed. This is called replace face. The replace face tool is extremely helpful when you need to extend or reshape your model based on another surface. So next one is thread and tabs. For that I am inserting another body. Hide this one. First one, rename this as thread. Okay, click on OK. For thread I will create a bolt. For that one I will use the YZ plane to create the base feature or the bolt. I am creating a simple bolt to analyze the thread tool. Let's say this is 6 mm and this is 4 mm. This is 2.5 mm and length is 20 mm. Okay, or you can say 3 mm actually. Length is 20 mm. Click on the exit workbench use the shaft, give the axis, this is created. So the head should be not round, so click on this face. I want the head should be hexagonal, click on the hexagon. Okay, and give the this value, the across flat value will be 10 mm or 11 mm if I say yes, this is good. And click on the exit workbench, remove this up to this one. Let's say here, can you use the up to next option? You can see, but this is up to next, up to this one. Okay, but if I remove this one, this will remove all. For that one, I will, in the sketch, I will add a circle here and keep this dimension of this circle as 15 mm. Okay, go on exit workbench. Now use the pocket command and give it to up to next and click on preview. Now you can see this is created. Okay, now a bolt is created. Now give the thread to this one. To keep the thread, click on the thread tab option. Now select the face where you want to give the thread. In thread tab definition window also you can see the drawing. This is your lateral face, this one, and select the limit. Okay, I am selecting this one as my limit now. This is thread. Okay, and type here. You can see thread and tape. This is this select automatically. This is a thread, and select the dimension here. Type metric thin pitch I am selecting. In thin pitch 6 mm diameter is not available, so I have to choose the metric thick pitch where I can find the M6 thread. Why this selects automatically? Because I have give this diameter as 6 mm. I have created the 3 mm in the sketch which I have rotated about 360 degrees, so this will create 6 mm diameter. So this is M6 and the thread depth will be 10 mm, and click on preview. Here the support limit is different, so I will change this support limit to here. Now we can see, and click on preview, and you can see the threads, and click on OK. In CATIA this will not show you the threads like this. In the preview you can see the symbolic representation here. You can able to visualize. Okay, this is in CATIA the thread representation will not show. This will always show you the flat surface, and but in drafting it will show you the thread representation. So this is called thread option. Okay, now let's create a tape. For that, to create a tape I am inserting another body and renaming it to hide this one. To create the tape, I am selecting again the YZ plane, click on the sketch tool. I will create a nut here. To create a nut, I will create a rectangle here. The whole diameter should be, let's say, 6 mm. To create a 6 mm, I create 3 mm dimension here, and this one is 4 mm or 5 mm, and the thickness will be 5 mm. Okay, or we can say 3 mm. Click on the exit workbench, click on the sharp tool, and select the axis as the vertical axis. And now I have this one is created, but this is not looks like a nut. To create a nut, first of all give the chamfers to both the side. This is 0.5 chamfer. Now, and by selecting this face, click on the sketch tool, select this face and create a hexagon like in thread, and another circle. Give this dimension, the across flat dimension, this is 9 mm, okay, or 9.5 mm. And this is 11 mm, let's say. Click on the exit workbench and use the pocket command. Up to next, click on OK. Now my nut is created. Okay. Now click on the thread and tape option and select the face or lateral face where you want to create the tape, and select the face limit. Now I have selected the face limit, and this is also, you can see, automatically diagnose or recommend the dimension, thread dimension. This is M6. We can easily create the M6 dimension here, and click on preview. Tape diameter must be greater than the support diameter. So here I will create M8. Preview, but this is creating problem. To create a 6 mm thread, we need material to be removed. So 6 mm, it must be less than 6 mm the support. So for that one, I will make this one as 2.5 mm. So now use the thread and tape option, click on the lateral face, click on the limit face, both are selected, M6 is selected, and click on the preview. Now you can visualize the tape. Okay, click on OK. But in CATIA you cannot see the visual representation of tape in 3D model. So thread and tapes. Thread features are used to create external threads on cylindrical faces, commonly used for bolts, screws, bottle caps, connectors, and more. And tapes are used for creating internal threads, such as those used in nuts, castings, housings, and components requiring threaded holes. So in In today's session, dress up features are incredible, used for refining your parts. Fillets are for smooth transition and give strength to your object. Chamfer removes sharp edges. Shell for lightweight parts. Draft for molding. Thickness for hollowing the surfaces. Remove face for cleanup. Replace face for quickly modify complex surfaces. Thread and tabs for nut bolts. So always ensure that the geometry is valid before applying multiple dress up features. Okay. If you found this tutorial helpful, please like this video and subscribe to Enginuity Lab and hit the bell icon for updates on upcoming lessons. Drop your question or suggestions in the comment below. Thank you for watching Enginuity Lab. See you on next video.